Hello, everyone. Today we're going to continue with stoichiometry, and we're going to be discussing the limiting reactant. The limiting reactant, in short, is just the reactant that you are going to run out of first. So it is the reactant that is going to limit how many products you can make. Okay. Again, if we think about it like a recipe, it's like an ingredient that you don't have enough of. You need 2 pounds of flour to make something, you only have 1 pound. So your flour is your limiting reactant. You don't have enough of it to make whatever product that you need. Okay. So here's a quick example. We have hydrogen and we have chlorine making hydrochloric acid gas. Okay. What they're saying is we have 10 moles of H2 and we have 20 moles of Cl2. And they're saying which one's going to run out first. Well, let's look at the equation and look at the coefficients. So there's no number here, which means it's 1 and 1. So for every hydrogen molecule, for every one hydrogen molecule, you need one chlorine molecule. So it's a 1-to-1 ratio. So you need the exact same amount of both. So if we have 10 moles of hydrogen and we have 20 moles of chlorine, which one's going to run out first? Well, I think that it is obvious that it is the hydrogen. The hydrogen is going to run out first, okay? When we do the reaction, how much chlorine are you going to have left over? Well, how much hydrogen are you going to use up? You're going to use up all 10 moles, and it's a 1-to-1 ratio. So when you use up the 10 moles of hydrogen, you're going to use up 10 moles of chlorine. What are you going to be left with? You're going to be left with 10 moles of chlorine. And that is what this piece is right here. This is your leftover. And that's the concept you guys are looking at in that game challenge that I had you guys do. Now we're starting to look at it now. So in this case, hydrogen would be considered the limiting reactant. It's the limiting reactant because it prevents us from making any more product. Chlorine would be the excess reactant. We have an extra amount of it. And you guys have seen that term used in problems. If a problem says we have a chemical in excess, it means pretend you have an infinite amount of it. You have enough to do what you need to do. Okay, so you have the limiting reactant and you have the excess reactant. So again, the chemical equation is calling for 1-to-1. So you combine one hydrogen and one chlorine and you get your HCl. But you don't have enough hydrogens. You're going to run out of hydrogen before you run out of chlorine. Okay. So 1, 2, 3. So here you have 10. These are the 10 moles. They have it represented with 10 pairs. So 10 pairs of 10 moles. Here are your 10 moles of chlorine, and then you have an extra 10 moles down here that you can't use. So that's the concept of limiting an excess reactant. Now, if in a problem, how would you figure out which one is the limiting reactant when it's not this simple? In this case, it's fairly simple because it's just 1-to-1. So you need the same amount of both either way. So it's easy to tell, but that is not always the case. Okay. So firstly, I want to get rid of a misconception. So the limiting reactant is not necessarily the one with the smallest mass. Okay. So the whole point of this statement is basically to tell you that you can't look at mass and figure out which one is the limiting reactant. You must be in moles. Okay, you must be in moles. So, for example, in this case, we have 10 moles of hydrogen and we have 20 moles of chlorine, right? So, a mole of hydrogen is going to be 2 grams. So if we have 10 moles of hydrogen, that means we would only have 20 grams of hydrogen. We have 20 grams of hydrogen. Chlorine, the molar mass of chlorine, of one chlorine, is 35.45, which means we can round that up to 1 mole being 71. Let's say 1 mole is 71, and we have 20 moles of that. So then 71 times 20 That's going to be about, let's see, 14 add two zeros. Let's just, to make it a clean number, it's going to be about 1,400 grams. Okay. So if you look at the mass, you have way more chlorine than you do hydrogen, but you don't use up that much hydrogen. So 1 mole of hydrogen would only be 2 grams versus 1 mole of chlorine would be 70, almost 71 grams. So it doesn't match up. So you need to be careful when looking at mass if you're trying to use that to determine which ones you're limiting. You can't. It's difficult to do because not every atomic mass or molar mass is going to be the same. So when you're looking at limiting reactants, you need to look at moles. Okay, you need to look at the moles. Anything else will confuse you. So how would we determine this if it wasn't a simple one-to-one? First steps first. If it wasn't already in moles, you need to convert everything into moles because of what we just talked about. These are going to be your initial amounts of each reactant. And then the rest, divide by the coefficient, and the smaller number will be your limiting reactant. Divide by the coefficient, and the smaller number will be your limiting reactant. And let's do an example. So here we have a chemical reaction. We have nitrogen reacting with hydrogen to make ammonia. This time, the coefficients aren't all the same number. We have a 1, we have a 3, and we have a 2. So we want to figure out which one is the limiting reactant. What are we given? We are given 10 grams of hydrogen, and we are given 3.4 moles of nitrogen. We want to know which one is the limiting reactant, okay? Well, step 1, convert everything to moles. This is already in moles, 3.4 moles of nitrogen, but the hydrogen is not. So you have 10 grams of hydrogen gas. To convert that to moles, you got to divide that by the molar mass. In this case, they have it set up in the ratio. So 1 mole of hydrogen gas is the same as 2 grams of hydrogen gas. The grams cancel, and you're left with just moles, and you end up getting 5. So we have 5 moles of hydrogen gas, and we have 3.4 moles of nitrogen gas. Okay, now let's look at the recipe or the chemical equation. To follow this recipe exactly, for every 1 nitrogen, you need 3 hydrogens, which means you need triple the amount of nitrogen in hydrogen. With that in mind, you can do what's 3 times 3 in your head. You know right away, 3 times 3 is 9. This is more than 3, so if you triple this, you're going to need more than 9 moles of hydrogen. We only have 5, so right away you know that the hydrogen, we don't have enough hydrogen. That's right away. Once you get better at that, you can do that right away. But if we continue following the steps, the next step is to divide the numbers by their coefficient. So we have 3.4 nitrogen, 5 hydrogen. What's the coefficient? This one is going to be 1. This one's 3. 3.4 divided by 1 is going to be 3.4. 5 from the hydrogen divided by 3, again, we're dividing by the coefficient, is 1.66. Okay? So what this tells us is because this ends up being smaller, that means hydrogen is your limiting reactant. What this division does is it tells you how many times you can do the reaction. So if we were just looking at the nitrogen, we can do this reaction 3.4 times. If we were looking at the hydrogen only lets us do the reaction 1.66 times, okay? So because this number is smaller, that means this is the one that's going to run out first. And that is how you determine the limiting reactant. Okay, let's do another one. We have 10 moles of hydrogen and we have 7 moles of oxygen. We want to know which one is the limiting. Okay? So we have 10 of this and we have 7 of this. Step 1, convert them to moles. They're already in moles, so this step is done already. Step 2, divide your molar amounts by the coefficient. The coefficient with hydrogen is 2. 10 divided by 2 is 5. Okay. Oxygen, we have 7 of it. 7 divided by 1 is 7. Which number is smaller? That would be the 5. So that means hydrogen is, again, the limiting reactant. If you look at the recipe, it says for every 2 hydrogens, you need 1 oxygen. So you need half the amount of hydrogen in oxygen. So if we were looking at exact numbers, if we knew we had 10 of this, we would only need 5 of the oxygen, but we have 7. So we have extra oxygen. Okay, oxygen in this case is an excess. Hydrogen is the limiting reactant. Hydrogen is what's going to run out first. Okay, and that's the whole idea behind limiting reactants. Right. So it's just about, once you figure out how many of each you have, divide it by the coefficient, and that's how you figure out which one is going to prevent you from continuing with the reaction. Okay. So I'm going to do all the examples I'm going to do today are from the are going to be from the presentation. In the class set, today we are doing class set 3. The new addition today is going to be the idea of the limiting reactant. So what you did in set 1 and set 2, you're going to continue. But now we're going to add a new component, and that is the limiting reactant. Okay? So in class set 3, which material would be the limiting reactant? That's the new component. In number 1, 1C, and the same thing in number 2. In number 2, in part B, they're going to ask you the consumption, where, well, either way, that's the new component. Well, what I want you to skip some things, because in class set 3, they add 2 new things, but I don't want to add them both at the same time. So they start talking about theoretical yield. Theoretical yield is for tomorrow. So I want you to skip part B in part C. Okay, so be careful with that. I want you to skip part B in part C, and I'm going to write this in the announcement as well. And I want you to skip D, because D, it's talking about oxidation and reduction. We're past that. We're not worried about that. And then I want you to skip part C and D in number 2, because this is talking about theoretical yield, which again, that's for tomorrow. And this is talking about Lewis structures. We're past that. I don't want to focus on that. Okay. So the new part is the limiting reactant, which I'm surprised. I thought number 2 had something about that too. I guess not. But that's the new piece for today. So 1A, B, and C. In C, just part A, skip part B, and ignore D, and I'll write that out as well. But this is what you're doing for today. And because there aren't that many examples in here, that, I mean, if I did one, that's a lot. That's already done for you. I don't want to do that. So I'm just going to continue going through the examples in the presentation. Okay. So rather than just being given the moles right away, this is a more realistic example of what you would see in the worksheet. Okay, so if we wanted to figure out which one is limiting, first thing we got to do is convert everything to moles first. So this is where the math portion comes in a little bit. So they're not going to give us moles right away. Okay, so in this case, they tell us grams of water. So we have water and oxygen reacting to make. This is hydrogen peroxide. That's hydrogen peroxide, the disinfectant. 36 grams of water, and we have 44.8 liters of oxygen. So, and they give us mass for one and volume for the other. Step 1 in this case is converted again to moles, as always. To convert the water mass to moles, you got to divide by the molar mass. In this case, the molar mass of water is 18. So 36 divided by 18 gives us 2 moles of H2O. You have 44.8 liters of oxygen. You got to divide that by the volume at STP. This is the big sign, remember that, which is 22.4. Divide this by 24 and you get 2 moles of oxygen. So now you know we have 2 moles of both. Now that we know how many of each mole amount we have, step 2 is divide everything by the coefficient. With water, it's 2. With oxygen, it's 1. 2 divided by 2 is 1. 2 divided by 1 is 2. Which one is smaller? That would be the 1. So water, in this case, is the limiting reactant. Hope you guys are getting the idea. Okay? So let's do the rest. I'll do, oh, there's only 2 examples left. So, or 3. So I'll do these real quick and we will call it a day. In this example, blank is the limiting reactant. So what is going on? What is reacting? We have hydrogen and oxygen reacting to make water. So hydrogen and oxygen are reacting to make water. This is the chemical reaction. H2 plus O2 makes H2O. Now, even without the chemical equation, you can answer this question. And you can do that by just looking at which one do you have left over. So the gray is the hydrogen and the red is the oxygen. If you look at the end, so after the reaction, which one do you have left over? I see oxygens that we have left over. And because we have oxygens left over, that means we ran out of hydrogen first. So the answer here would be A. Without doing any math, I can see that the answer is A. But let's say I wanted to solve it normally. I will do that now. So we have the chemical equation, but we need to balance it. It's not balanced yet. So we need a 2 here. And we need a 2 here. Okay? So that's the balanced chemical equation. 4 hydrogens, 2 oxygens, 2 oxygens. How many do we have of each? We have 10 moles of hydrogen, and we have 7 moles of oxygen. Hydrogen, we got to divide it by 2. Oxygen, we got to divide by 1. This is going to come out to be 5, and this is going to come out to be 7. 5 is smaller than 7, and 5 is the hydrogen. So 5 means that hydrogen is the limiting reactant, okay? So that's 2 ways you can answer these types of questions if you're ever given a diagram. I knew right away it was hydrogen because I don't see any hydrogens left over. I see oxygens left over. But if you wanted to actually calculate it, this is how you would calculate it. And you can see that they both prove that hydrogen is the limiting reactant. Here's another more realistic example. We have 33 liters of nitrogen gas and we have 12 grams of hydrogen. It's saying that the hydrogen is excess. The hydrogen is excess, true or false? We need to prove that. So we got to work from scratch. Step 1, convert everything to moles. We have 33.7 liter, or 33.7. We have 33 liters of nitrogen. We need to convert that to moles. And you do that by dividing the 33 by 22.4. Again, that comes from the mole chapter. And we will get, let me get my calculator. 33 divided by 22.4 comes out to be 1.47. And then we have 12 grams of hydrogen. And then we need to divide that by its molar mass, which is 2. Two grams per mole. And then if you do that, you get 6. Okay? So now we know we have 1.47 moles of nitrogen, and we have 6 moles of hydrogen. 1.47 moles of nitrogen, 6 moles of hydrogen. Now, the final step, or step 2, is now we got to divide everything by the coefficient. This is going to be divided by 1. This is going to be divided by 3. So this comes out to be 2. And this is going to come out to be 1.47. Which one is smaller? The 1.47 is smaller, which means nitrogen is your limiting reactant, and that makes hydrogen the excess reactant. So the answer here is A, true. And then 42, we have 120 grams of zinc and 2.1 moles of hydrogen ion. So we know this one right away. This is 2.1 moles. What we don't know is how many moles of zinc we have. So let's figure that out. Go to the periodic table. Zinc is Zn. What is the molar mass? The molar mass is 65.38. So we need to convert the 120 to moles by dividing it by 65.38. So 120 divided by 65.38. That's going to be equal to 1.8, round that to 4, 1.84. Okay. And now to figure out the limiting, we got to divide them by the coefficient. So this is going to be divided by 1, and this is going to be divided by 2. So this is going to end up being 1.05. And this is going to be 1.84. Which one is smaller? The 1.05 is smaller. So therefore, the hydrogen is the limiting and zinc is the excess. So the answer to this question, it says that the zinc will limit the reaction. That is false. Zinc is not going to be the one that limits this reaction. It is going to be hydrogen. The hydrogen ion is what's going to limit this reaction. Okay? And that's it for limiting reaction, or limiting reactant, not reaction. Okay? So what you're going to be doing today, they both ask you to balance the equation first. And number 1 and number 2, you have to balance the equation. And number 1, you're given the equation. And number 2, it doesn't give it to you, but it tells you what's happening. It tells you that the C2H2 is burning with oxygen to make carbon dioxide and water. If you remember, that is a combustion reaction. Okay, so this is reacting with oxygen, and you're making carbon dioxide and water, and then you have to balance it. After you balance it, then you can answer the questions, and it's the same thing you did in set 1 and set 2. Okay, so they're going to ask you to convert certain things or figure out what it is that you're trying to, which one's going to run out first and things like that. So it's what you've done previously, just now with the addition of a potential new question, which is the limiting reactant. Okay. Thank you guys for your time. I wish you all the best. That's it for today. We're going to wrap it up. Tomorrow we will be doing the yield. And yield, all that is how much of something, it's a conversion rate. So if we have 10 grams of something, how much of it do we convert? That's what yield is. And that's what we'll talk about tomorrow. Okay? But take care, guys. Have a good one.